Good afternoon, ladies and gentlemen. It is 12:48 on a Thursday, April 15th. I'm your host, Mr. Kaya, and we're going to be talking about properties of logarithms. Okay, so not a whole lot in this particular lesson. Okay, shouldn't be a very long video, and basically the purpose of this particular lesson is just getting comfortable being able to, well, manipulate these logarithms in order to, essentially solve problems and get what we want, okay? So just like any sort of, math topic, right, we're always doing weird things with problems in order to sort of solve them, right? And so these properties will eventually help us to solve problems involving logarithms, okay? But for now, we have to know what these properties are, okay? So the first property is called the product property, and it states this, okay? When you got the log of b the log of b of x and y, okay? Then what we can do is we can write the log of b of x plus the log b of y, okay? And so it means the same, right? These things are equivalent, okay? Just different representations of the same thing, okay? And so the next one is the quotient property. And if we recall, right, when we were doing exponents, right, when we're multiplying involving exponents, what do we do with the, when you have the same base, what do we do with the exponents? We add the exponents, okay? Same sort of concept here, right? When we're dividing with these guys, okay, up above we add them, down below we just subtract them, okay? The third property is called the power property. And what that states is you can take this n and you move it right to the front of the equation. Okay? And then the last one, we're changing our base. Okay? Now we won't see so much of this in this particular lesson, but don't forget that property because that'll play out a very important part in order to solve equations involving logs down the road. Okay? But anyway, let's get down to some nitty-gritty. And that's it. Those are the only four properties that we're going to get from this particular unit. Okay? So when we're multiplying these guys, you separate them by a plus sign, log b of x plus log b of y. When we're dividing, log b of x minus log b of y. And then with the power property, you just take that n and you move it towards the front. Okay? So anyway, let's do some problems here. All right? So it says expand the logarithmic expression. Okay? And so what you're going to be doing here, all right, is pretty much, we're going to be expanding them in 1, 2, 3, and 4. So we're going to be using our properties to make it look larger. And then as you can see down here, we're just going to be going the opposite direction. And that is it. That is all the lesson is for the day. And then here's your homework. And again, you're responsible for the odd problems. Okay? So, being said, all right, let's get down to business. So this guy, all right, it's just going to be the log of 15 minus the log of y. That's the first one. Not too bad, right? Now, the second one and the third one involve a couple of different things. Okay, first we got to recognize, okay, what's being multiplied here? So this is technically 2 times x to the 6. Okay, so what you want to do first is you want to actually separate those two pieces. So let's go ahead and do that now. Log of 5, 2 plus log of 5 x to the 6. Okay, but then we're not done yet. Okay, we got this 6th power up here, right? And so what we can do with that is move that guy to the front using our power property. And there's our equation. Going on to the third one. Okay, this was xy divided by 12. So let's go ahead and separate those pieces first. xy minus log b of 12. Okay, and then we're going to keep working backwards. And so this is going to be log b of x plus log b of y minus log b of 12. Okay, number 4's got a little bit of a trick in the sense that, all right, it's got this radical here. And so anytime you have to, start out with a radical, right, that isn't really one of our properties, right? So we're kind of stuck here. But then using our intuitiveness, I realized that, okay, well, the cube root of something, it'd be the same as just taking x and raising it to the 1/3 power. And now we can simplify this guy. So I'm going to take that 1/3, and using the power property, I'm going to put that guy in the front, log b of x. So piggybacking off that, we're going to do the same thing here, except this is going to be log b of x squared y raised to the 1/5 power. And so I take that and I move that to the front. And then I separate those two guys right there. So this is going to be 1/5 parentheses, right, because that's multiplying both of these pieces, log b x squared plus log b of y. But, gosh darn it, we're still not done yet. And so, Mr. K is running out of space. Whoops. Okay. So now it's going to be 1/5. Whoops. One-fifth, parentheses, 2 log b of x plus log b of y. Okay? And so the following 5 examples is just going back the other direction. Okay? So my advice for these would be just like how we read, right? We read left to right. You want to sort of deal with these the same way. We're going left to right. And so the first thing I'm going to do is I'm going to sort of, well, I see these 2's and 1/2's in front of my log, so I'm going to put those where they belong. All right, so I'm going to put this is going to be x squared plus log b y to the 1/2 minus log b to the z. Okay. Before I continue on any further, okay, it's helpful to point out that all of our bases here are b, right, which allows us to sort of carry out these properties. All right. If for whatever reason this wasn't a b, maybe this was a, okay, well, we can't do anything with those. Okay. So it would basically have to stay as is, right? So the only way these things work is if we have the same base, just like we had, you know, with exponents and stuff like that. You know, if we certainly can't combine these two, right? But if this was x times x squared, of course, right, we have the same base. Okay, so the same sort of property continues here, right? Remember, logarithms are just inverses of your exponential functions. Okay, so anyway, next part, okay, reading left to right, I'm going to combine these two guys. So log b x, x squared times y to the 1/2 minus log b of z. Okay, now remember, anything raised to the 1/2 power is just like taking the square root. As if you notice in the instructions, it says, if necessary, write in simplest radical form. Okay, which I'm going to do that, right? But I'm also going to take these guys right here, and these guys are all going to be divided by z. So log, log b of x squared square root of y all over z. Let's go on to the next one. Okay, reading left to right. All right, so we're going to go bring that 2 on there, so it's going to be log b 5 squared plus log b 3 plus log b 2. All right, notice we all have the same basis, so I know that I can put all of these guys together. So we'll start with the first 2 pieces, so it's going to be log b of 5 squared times 3 plus log b of 2. And I'm also going to combine those other guys. So 5 squared, 3, and 2, and all of that is equal to 150. Okay, next one. Again, same sort of process, take it left to right. So we're going to start with these 2 pieces. So the log b of w divided by x plus log b of y minus log b of z. Okay. Next, add these 2 guys. So by adding, I mean multiply. And so technically you got to figure this is a y over 1, right? So if I'm going to multiply wx times y, we're going to get wy over x minus log b of z. And our last part, okay, is that we're going to have to divide all of this by z, so log b of wy over x, all divided by z over 1. Right? And so what do we know about dividing by 2 fractions? KFC, keep flip change. So log b is equal to wyx times 1 over z. And there's our answer. Number 4, okay, going left to right, we have the same base, so that's good. I'm going to take those numbers located in front of those logs and put them where they belong. Okay, oops, there you go. All right, and then the last part, okay, because we're subtracting, that means I'm going to divide this guy by this guy, which is just equal to log 3 of 49 x to the 5th power. Number 5, and our last one before the homework, yippee. All right, going left to right, so first let's put that 2 where it belongs. Let's combine these 2 guys right here. So log of 6 times 4 minus log of 3. And then again, put these where they belong. So 24 divided by 3, which is equal to the log of 8. And that is it. Okay? So, being said, you guys are in charge of all the odd problems. So 1, 2, 3, 4, 5. Woo! A total of 6 questions. All right. So my anticipation is that we'll probably use the even ones to sort of practice these guys in class. But anyway, good luck, you guys, and hope this video helps. And make sure to look for the answer key.